Hello everyone, this tutorial is on how to solve a first order linear differential equation. Not all the time we have equations in which x and y are easily separable, and sometimes it's just impossible to separate them. So we need to look at other methods by which we can solve our equation. So one of those methods is known as linear differential equation method. Now let's just see what a linear differential equation actually looks like. A first order differential equation, linear, is one that can be put into the form dy over dx plus f of x into y equals to g of x. Now please note that fx and gx can only be functions of x, or fx or gx can be functions of can be a constant. Like for example, you can have a constant number 3, for example 3 here, or constant like 2 over here. So the f and g functions can only be functions of either x or be a constant function. Alright, so let's just move on to our example problem so that we can understand this concept further. So here we have a problem. Dy over dx equals to 2x into y plus x cube. Now step 1 is to bring this equation into the linear differential equation form, which is the one I just showed a couple of seconds ago. Dy over dx plus f of x into y equals to gx. So looking at this form, we bring the 2 over x on the left side, so this becomes a negative, into y equals to x cube. So our function f would be equal to this, which is negative 2 over x, and our function g would be simply x cube. So now we need to find our integrating factor. Integrating factor is equal to exponential power integral of fx times dx. So we plug the value of fx, which is our negative 2 over x times dx, and when we integrate this term, we get negative 2 ln of x, and this negative 2 would go as the power of x. We know this from the natural log property of ln, and this e would then cancel out with this ln, so we're left with x to the power negative 2, or we can also write this as 1 over x to the power square, 1 over x square. So this is our integrating factor. Now once we have our integrating factor, we then simply multiply this factor with our original equation that we transformed into a linear differential equation. So 1 over x square, which is our integrating factor, multiplied by our equation, so this becomes dy over dx into 1 over x square negative 2x into y into 1 over x square into x cube into 1 over x square. This would remain as it is, and this would become 2x cube times y, and these would cancel out, so we're left with x on the right side. Now if you notice, this whole term is the differential form of the product rule. The product rule was uv dash plus vu dash. So when we integrate this whole term, we would simply get 1 over x square times y, and the integral of x would be x square over 2, and of course our constant of integration. So we can simplify this equation by multiplying it by x square. So this becomes y equals to x to the power 4th over 2 plus x square into our constant of integration. So this is our answer. So whenever we have a differential equation in which we cannot separate the x from the y's, so we use a method which is known as linear differential equation method. We first bring our equation into the linear differential equation form, then we take out our integrating factor, and once we have the integrating factor, we just multiply it by our original equation, and then we integrate both sides, and once we are done with the integration, we simplify the terms, and we are left with an answer like this. So this is how you solve a linear differential equation. Thank you.